they see a cup of clear water, they would automatically assume that it's clean, so they will drink it without doubt. So why is it so important for us to build water purification system to developing countries? Well, it will improve the health of the community, as you can see from the data. But it also turns out that countries with better access to clean water have improved in their economy more than the other countries who don't. First of all, individuals, now they don't have to walk miles and miles a day to get clean water, so they can use their time to farm or do something for their family or get jobs. In a bigger scale, the country will improve in economy because its citizens will be living a more productive lifestyle. Also, decoupling the water economy from the amount of annual rainfall, it will boost up the economy because the country won't have to worry about getting its citizens clean water, so it can concentrate on more other urgent issues such as poverty or diseases.
In response to this issue, a nonprofit organization called Engineers Without Borders USA has stepped in to implement sustainable solutions in these countries that will help them. And one of their main focuses is the water crisis. So they try to make these communities self-sustainable so people don't have to come in and keep fixing the system. And right now, the Rutgers chapter has projects in Guatemala, Kenya, and Thailand. We're going to focus on the Guatemala project. The town is called Nueva Santa Catarina Ixtahuacan. It was originally Santa Catarina Ixtahuacan, but Hurricane Mitch destroyed it in 1998. It was relocated about 20 kilometers away, and everything was newly built, except the only problem they faced was getting water, because the closest water source is about 5 miles away. So a distribution system was put in, but since then it has decayed and it needs a lot of repairs. So the Engineers Without Borders have gone in and replaced pipes. As you can see, these are the springs and pumps, and all the way over here is a head tank in the community, and that's about 5 miles. So without the system, the villagers would have to walk 10 miles a day to get water.
So here's the basic overview of the area. As you can see, that's the distribution tank and that is the town. You can see that it's pretty far, it's 5 miles away, so people used to have to walk 10 miles back and forth in order to get water. This also shows why the EWB USA wanted to implement pipelines connecting these two, so that the townspeople could get water in their town without have to walk every day.
This is a diagram of our prototype. As you can see, it looks exactly like that. There are 5 steps to the purification process: aeration, coagulation, flocculation, disinfection, and filtration.
Right, aeration and coagulation. Aeration purifies water by exposing the water to air through turbulence, and it removes dissolved gases in the water. It also oxidizes or reduces molecules like carbon dioxide. Referring to our design, here's our aeration unit. We based off our design off of waterfall aerator, which used gravity to pull the water from the top to the bottom. We let the water go through and cascade down to the bottom so that it provides the water turbulence. And waterfall aerator is good for communities like Guatemala, where there isn't as much energy as there is in the United States. We also angle the cascades because since the aeration is our first step in our water treatment, we wanted the larger particles to get caught in the middle while the water can flow down the unit. Coagulation. The original water source had chemically charged ion particles that float in the water because they're attracted to polar water molecules, like attracts like. So what a coagulant does is that it neutralizes those particles so that the water, they won't be attracted to the water molecules anymore, and they'll eventually float down to the bottom. Here is the funnel for our coagulation. We dissolve alum in the water to make a coagulant solution. We use alum because it's a preservative easily found in any of the grocery store. It's cheap and it's not dangerous. We combine the aeration and coagulation system together while thinking that we needed to figure out a way to effectively dissolve the coagulant solution to the water. And we figured that if we combine these two together, it will mix the coagulant with the water effectively. Next one is flocculation. Basically, it is the clumping of the neutralized particles to form agglomeration. So the water will come down from the aerator and the coagulation. It will slow down in this part, and so that it will give the neutralized particles to clump together. And we angle the bottom so that the water can effectively flow out to the next station.
Okay, so the next step is disinfection. For disinfection, we use a chlorine solution. What the chlorine does is it breaks into hypochlorous acid and hypochlorite ions. This reaction is called the free chlorine reaction. This attacks bacteria by attacking their lipids and enzymes, effectively killing all the harmful bacteria that can cause the sickness. This is our system, and as you can see, we have angled the cascades down this time just so it can mix the chlorine in. And then the last step is filtration. We use a mixed media filter, as you can see, with larger, coarser particles at the top and finer particles at the bottom. We use rocks, pebbles, and sand. What this does is it effectively catches all the solid particles out of the water because it catches onto the media.
Alright. So we use the water source from pond next to the Raging River, and then we went through a simple water test, and this is the result we got. It seems basically safe except for these two. Alkalinity, if it's too high in the water, it's bad because alkalinity is the ability for the water to neutralize acid. It's bad if it's too high because the water tends to get basic. And hardness, when it's too hard, is also bad because it means that water is containing heavy metal ions, which is bad for human body, and it's also bad for the metal pipe because it erodes them. Next thing we did a bacteria testing. Unlike before, we found out that the water wasn't actually safe. Bacteria testing, when the color shows yellow, then it means there is bacteria in the water, like harmful bacteria like E. coli, and if the color was purple, then it meant the water was safe to drink. But we got yellow, so it meant that we had to purify this water before being able to drink it.
Okay, so after putting the water through our filter, we got different results. First of all, you'll notice that our pH went low into the acidic range, which is because we used too much chlorine, which can be easily fixed. Also, the alkalinity was lower, which it's not good if it's too low either, because then it tends to be more acidic. Also, the hardness was lowered a little bit, but it's still too hard than what you would normally want. We also did a bacteria test after we filtered the water, and we didn't have any harmful bacteria after running it through our system. Turbidity is the measure of suspended solid particles in a liquid. As you can see, before there's a lot of solids in there, and then after you can see it's clear and clean.
Scaling to a larger system. So we built this prototype, but we also had to think about how we are going to implement this to the bottom of society. We also wanted our prototype to be sustainable. We wanted our prototype to follow the social norm of the society. So we were going to work with the water committee of the community. We would concentrate on educating the people the importance of clean water and why they have to filter the water before drinking. And we will educate how to sustain the system